All right, well, welcome everybody. I'm Brandon Sullivan. I'm a Fast & F employee, but I run this space, the Concept Lab. So I'm really fortunate we get to do a bunch of testing, product development, structural research, helping to advance structural research and trying to come up with new products for our profession.
So I'm going to talk for a little bit about some of the background design thinking behind the project. Many of you have probably seen parts of this before, but I'll try and go through it as promptly as I can, because it's kind of important context for why there's a lot of prefab in the project, why the building is in the form that it's in. And then we're going to hear from Sean from Kindred and Kevin from TAG about the kind of implementation once design is complete, about trying to make things happen on site and in the prefab plant. So just first like to acknowledge that we're on the traditional, ancestral and unceded territory of the Musqueam, Squamish and Tsleil-Waututh nations. And as you know, we're going to talk about Vienna House. So it's a 6-story over 1-story, so technically a 7-story kind of hybrid of mass timber floors and panelized light wood frame walls. It's got 123 apartments in it, and it's been on site for a year and 4 months or so. So we had some written objectives at the start of the project. It was very useful. We had a written project charter, which is quite rare, and it was quite detailed. So the objectives were to deliver a near zero emissions building, which took the form of a passive house certification, enhanced climate resilience, to maximize offsite fabrication, and then a knowledge transfer about what was learned along the way. Obviously to improve the supply of affordable housing by providing 123 apartments in an area of the city that really needs it. To maximize the investment, because it's City of Vancouver's land, and obviously public money in the form of BC Housing and CMHC funding, to utilize renewable materials, and then to deliver the project on schedule and on budget. And that's the location of the project, just the red dot, just to the south of Trout Lake Park. So in terms of the timeline, we're in January 2025. The project has a very long history, which goes all the way back to 2018. So there's a memorandum of understanding between the City of Vancouver and the City of Vienna around the delivery of social housing and a knowledge transfer with that, and exploring wood construction and prefabrication and so on. And there's a number of project partners, too many to go through really, but obviously City of Vancouver as a landowner, More Than a Roof Housing Society, who I'll talk about in a moment. Obviously Kindred Construction is building the project. Some of our key engineers are Introba, doing mechanical, electrical, energy modeling, life cycle assessment, Wikihurst Maver on the structural engineering side. And then there is a Vancouver house in Vienna that's also under construction at the moment. That project deserves a presentation in its own right, given by the team over there. It's very interesting. They've been through really huge pricing shocks due to the war in Ukraine and everything. So issues around energy and the availability of timber, a lot of it coming from the East and Europe. So they've had a lot of ups and downs and delays and value engineering and things. But they have a very interesting project with a lot of quite innovative offsite fabrication. So this is a photo, 2 photos from this month of wall panels ready to be delivered to site. So they're actually delivering wall panels with cladding on, windows in, and then they have mass timber floor and vertical structure as well. More Than a Roof Housing Society is a really key part of why the building is in the form that it's in, and that the kind of values that are in the project charter are really embedded in the design. And crucially, they were involved even before the architect and design team was brought on board. So it meant that we could get their support for early design decisions. They were always in the room and always kind of advocating for the final occupants and tenants in the building. So this is the program of the building, from studio to 4-bedroom units. 46% of them are family units, so that's 2-bedroom and bigger. 100% of the units are adaptable because it's City of Vancouver VBBL requirement. More than 10% of them are fully accessible. So we've got not a lot of parking space in the building, a lot of bike parking though. And that's got kind of implications for construction sequencing and the size of the parkade and everything, which we'll talk about later. And then this is the building as it's more or less the state on site at the moment, the building in the foreground, in the middle with the city in the background. And just to talk a little bit about the site context, because the form that the building's in and some of the ideas around it really emerge out of some of the site constraints. So acoustically, the SkyTrain borders the site immediately on the north side. I think it's about 8 or 10 meters away from the north face of the building. So you've got the expo line going by a train every sort of 90 seconds in one direction or another, and kind of noise levels that are like a construction site at its peak. So that's kind of constant, about, I think it's 18 hours a day or more of noise. So it's acoustically very challenged. It's also got Victoria Drive, which is kind of an arterial producing almost as much noise itself. So we had this kind of challenge about how to design the building and give people private outdoor space or shared outdoor space, which wasn't dominated by the effects of ambient noise. So there's just an idea of how close the SkyTrain is. This is the 3rd floor under construction. And yeah, it's very close, and the proximity creates some issues for construction. The site's very constrained, but these acoustic issues start to really shape the building form. So by creating a courtyard, we're immediately seeing a 20 decibel drop in noise just with the architectural form of the building. So we're able to create a much quieter kind of acoustic oasis in the middle where people can socialize. And crucially, they can open their windows to that space, leave open windows in the evening and not be disturbed by traffic noise. And then we were also designing in the summer of 2021 during the heat dome. So that really focused everybody's minds on what kind of stresses and events the building and its occupants might be subjected to in the future. We kind of got a real world taste of how poorly some of our building stock was performing at that time. So it really focused everybody's mind on what does climate resilience mean, what kind of systems are failing or not delivering at the moment, which you'd expect to continue in the future or get worse even. And that leads to this plan, which is essentially giving all units cross ventilation. So you've got natural light from 2 sides. Everybody has their own exterior front door. I suppose this was part of kind of selling this idea to the broader client group that natural ventilation, when you can really rely on it, requires like full cross ventilation. I think we've seen a lot of buildings overheating, which have made assumptions around openable windows, which haven't really been borne out in reality, where you have apartments that just face a single side, often towards traffic noise, and people just aren't going to leave their window open when they want to go to bed. So you're just getting lots of solar gain and no ability to purge that warm air at nighttime. So having the courtyard and the stack effect through there really helps to drive a kind of cooling effect. We do also have a cooling system in the building, mechanical cooling, but it's about kind of creating some redundancy so you're not over relying on any one system. So this is a look inside the most common unit type, which is a 2-bedroom unit. Because it's a 6-story building technically, it doesn't come with a restriction on the amount of exposed mass timber. So we're putting additional gypsum board in the bedrooms because they all stack to further improve acoustic performance. But in living spaces, we're using the underside of the mass timber panels as the ceiling finish. And to do that, it requires kind of focusing your mechanical systems and your ceiling design to try and consolidate them as much as possible. So we have this kind of bank of kitchen, washroom, laundry, sidewall sprinklers, everything consolidated in one bulkhead where possible over the middle of the project to try and keep the ceilings elsewhere as clear as possible and allow them to be exposed. And so because of the focus on climate resilience, we have this kind of mixed mode approach to thermal comfort. So you don't just rely on full active cooling, which is quite expensive, firstly, and then obviously it doesn't function at all in a power outage, but you also don't rely completely on natural ventilation, which involves assumptions about occupant behavior that may or may not be borne out. So we've got these overlapping systems of mechanical cooling, adjustable exterior shading, natural ventilation to try and not be overly prescriptive about the way people will live in the building, but also be able to adapt to situations where you have poor air quality in the summertime, but high temperatures, and you want people to be able to keep their windows closed with fresh air, or it's a warm day in the shoulder season and people can just open windows and there's very little load on the cooling system. So this is just a diagram of how all the ventilation air is distributed through the building. So we don't have any fan coil or VRF system. It's just distributing pre-cooled air using the same ventilation air that's just provided for background ventilation. So there's a lot less refrigerant in the building. And it does depend on these other factors like appropriate shading and natural ventilation to try and reduce the load. And then we did model it in Troba, did some analysis in the 2050 climate scenario to see could we still meet the City of Vancouver and BC Housing's 20 hours of overheating limit. And that was borne out. Essentially, the ventilation system just ramps up in that case. It's oversized to provide higher volume of air when we need a lot of cooling. So even in a future climate scenario, it's able to meet the current standards. And then we're currently planning to incorporate a really large PV system on the roof. So we've kept the roof surface mainly kind of clear of mechanical equipment in the hope that we would get the PV system funded, and it looks like that's going ahead. And then we've got some CO2-based domestic hot water system up there. So in terms of prefab, we obviously had a pretty strong mandate from the client group to pursue this because it was a formal goal of the project. It meant it sort of gave us the latitude to explore options and to push things with the client and make proposals. And I think that really helps the site itself because there's so little laydown space. Once you shape the building as a courtyard, it's really filling almost all of the site as a building footprint. So there's very little area to stage materials or to store materials on site. So that sort of lends itself more to prefab and being able to just take panels from the truck directly into place. But then I'll maybe ask Sean to speak about it as well. The site has other adjacencies that make even the kind of craning and prefab operations complicated. So it's a difficult site to do site building or prefab on, but the prefab does have some kind of benefits that we're able to leverage. The slimmer floor panel dimensions did allow us to also kind of squeak in an extra floor that wasn't in the design when we started. So we're able to give a pretty comfortable floor-to-floor height, but also meet the 18-meter maximum height limit that combustible construction has. So were we building in TGI joists, we would either not be able to deliver a number of stories, or we'd have a kind of a restricted ceiling height in bathrooms and bedrooms and so on. And then we'll speak much more about the wall panels when Kevin gets up, but just to say these are closed wall panels prefabricated in Squamish, so they're coming with membrane on and airtight within the panel field itself and pre-insulated. And then we've got 5-ply CLT floor panels from Kolesnikov. And in addition to that, the walkways within the courtyard, because they need to be rated, it's a 6-story walkway structure. Those are steel deck with cast-in-place concrete on top and steel columns supporting them. And it's just a look at one of the units being framed, so you can see pre-cut surface penetration for a vertical shaft and the exposed ceiling in the living space of the unit. And then to kind of further maximize the prefab scope, we also have fully modular balconies that are fabricated off-site, made by a company called Sapphire. So those are aluminum structure, and they have an integrated drainage pan. Essentially, the soffit acts as a rainwater collector and diverts the water off. So there's no membrane work that needs to integrate into the building facade. They're just steel anchors that are attached to the wall panel, and then the balconies are fabricated off-site and just lifted into place and clipped on. If there's an issue, they can be replaced without removing the other balconies or having to remove cladding and redo membrane work. And I'll just briefly touch on embodied carbon, because I think there's a kind of tension with some passive house projects about the additional materials that might be required in order to reduce your operational emissions. So building thicker walls if you use the same materials, it'll just increase your upfront carbon, your embodied carbon. But I think that panelizing your exterior walls gives you this opportunity to use lower carbon blown insulation types like cellulose or like blown glass fiber insulation. So it kind of opens the door to doing lower carbon wall systems where you can essentially make the building more comfortable and more resilient without loading up on upfront carbon, particularly if your building is using wood structural systems. So just to look at some of the kind of high level impacts in the life cycle assessment. So obviously our insulation is shown here. It's actually quite low on the list because we were very careful about the spec for the foam plastics that are in the project. And we've got kind of lower carbon glass wool insulation that's pre-installed by TAG. And then the kind of main item left on the table is the concrete. There's no particular low carbon concrete mixture. It's just relying on the fact that there's a low volume of concrete. We've just got one level of parkade. We didn't have a formal embodied carbon target for the project. We were even ahead of the City of Vancouver's emerging requirements. So that's kind of low-hanging fruit for another project that we could have made big gains on that by adjusting the concrete spec. But even still, the low volume of concrete delivers a really, really low overall embodied carbon for the project. And then if you factor in biogenic carbon storage in the mass timber and in all the other wood products in the framing, then you start to get negative values that can rebalance against that. So I know different embodied carbon standards either include or exclude biogenic carbon, but it's interesting to kind of look at that as an aspect. And maybe I'll ask Kevin to talk a little bit about TAG panels, the work that they do, and some of the lessons learned on the project.
I'm going to talk a little bit about our panel assembly used for this project. I'll talk about some interesting facts, and then BIM and the importance of BIM management. This is the panel here we use for Vienna House, and working our way outwards there, we start off with the OSB. So that forms your primary shear and your primary air and vapor barrier. We pre-tape the joints in the factory, try to keep them airtight before they leave the facility. This project spec'd a 2x10, so we used 2x10 framing. And then moving outwards, we used a 1/2-inch exterior ply, followed by Mento 1000 as your WRB. And this project had no rain screening there, which is shown there. On the bottom, there's a few photos just in the factory there. That's a stack of exterior panels getting ready to get shipped. And on the right is a very empty framing table, but we typically have 3 or 4 panels at a time that we're working on those tables. Some interesting facts. Vienna House was a total of 1,638 panels. 531 of those were exterior panels, and then the remainder, 1,107 panels were party walls or load-bearing walls. That was shipped on a total of 44 50-foot flat deck trailers, and it took us about 3.5 months to model this project. I'm going to talk more about that in a second, with a production time of about 6 months. Most of our production time was happening as they were doing site work. And then the install, again, Sean could probably talk a bit more about this, but approximately 6 months to install steel, CLT, and our panels. So this goes into BIM, or leads into the importance of BIM management. So for us, everything starts with the modeling process. You'll see in the bottom picture there, that's just a massing model that we typically start with. We will combine the structural and architectural drawings into a 3D model. And from there, we'll start incorporating the structural components. So that's the picture above there. We're starting to populate that with actual structure. At that point, we usually come across a whole bunch of RFIs and will involve the consultants of the project. It was quite a lengthy process for that one. I think we had over 90 RFIs. There's quite a few. Seemed to be going on for a few months back and forth. Also during that stage as well, we're just finalizing the ROs and making sure everything's good to go for the next step, which would be incorporating other structural models. So this project had a steel model, had a CLT model, and then had our structural model, followed up with an MEP model. So 4 different models. We go first, meaning that we're obviously the first ones on site with our panels. So it's important that they all fit together in our model. So in this case, Kindred hired a third-party company, Modello, and they incorporate over models into one as a federated model. And they were helping with clash detection between steel, CLT, MEP, and our panels. We typically do that as well, and we'll do all the structural ones that we can find. But for a project of this size, it's super important to have a master model, if you will, or a federated model to review everything. I think Jamie had a couple of screenshots there, but when Modello put everything together, there was hundreds of clashes to work through. Last step for us will then be kind of or I just mentioned, the MEP model integration. We're also adjusting things. We're adjusting things for studs, or if there were joists, in this case, we'd move over floor joists, ceiling joists. This was CLT, of course. But we'll move over studs for mechanical runs. And then at that point, we're ready to finalize our model and we'll issue shop drawings. So we'll issue a finalized 3D model for review by the consultants, along with a 2D drawing set that the consultants can sign off on.
Thanks for coming out, everybody. A lot of familiar faces, so hopefully most of you know all this anyway, but I'll talk through it for humor's sake. I think as the builder, we can probably offer an element of lessons learned that might be useful for people perhaps looking to do this in the future or models like it. I've had the true privilege of being involved in Vienna House since October 2021, which is, given we didn't start on site until October 23, really quite an early engagement. Not to pump our own tires too hard, but that early engagement's pretty key in the prefabrication piece. You turned your kind of typical timelines on their head. The typical site built where everything comes in a certain order and everybody's got time to kind of get ready to do things don't exist in a prefab environment. And if you took one lesson today, that's the one I'd probably encourage you to take. Kevin's panels need to be designed months before they come on site. One of the challenges we then face is that the likes of certain funders, who I won't name, don't like paying deposits, which means prefab groups then either have to take a risk or it's a contractual negotiation. And if you can't realize that early start, then the benefits of prefab actually go out the window remarkably quickly. This can be a really quick, efficient way of doing stuff, but it has to have everybody in the chain tied together, pulling in the same direction. Not only did we have tag panels, we had Seola from Kalashnikov, we had Kalashnikov, we had sapphire balconies, we had prefabricated internal stick-built panels. This was a lot of pieces that all had to be organized really, really early on. Timeline-wise, turns it on its head. Double down on that, we had no basement in the building. I know we have a little half basement on one side, but typically if you were doing this as a, say, 4-story basement for a tower, you might have a year to try and get some of this stuff aligned. But where we were so shallow, we had like 3 months from contract signing to when we were going to pour our transfer deck and wanted to start bringing panels in. So I really had that as a consideration in terms of timings, because we didn't have them. So bear that in mind if you're in these sort of mid-rise single levels. Another challenge is trade knowledge. Like to my knowledge, nobody's done this typology before. We exist in a city where construction is rife, which is great for most of the people in this room, but it also means most trades can go and build something they've built 1,000 times before with pretty good cost certainty, know what to expect. They don't need to come and take a risk on something they might lose their shirt on. It's a point I'm going to build on with client groups as well, and the like bravery these things actually need. But from a procurement perspective, it was actually very challenging. The fact it had a lot of people in this room like pumping its tires and it had the eyes on it, like we managed to get some interest. But typically some of our less glamorous prefabricated projects, like actually getting trades to want to buy into it, has been a real challenge. A couple of pieces on kind of practicalities, again on lessons learned. Both Jamie and Kevin touched on the BIM model. I won't go super into depth with that, but I think having a clear BIM protocol is super important to the likely success of a project. It's a pretty new space, depending on if you work in airports and healthcare, yeah, a little more developed, but certainly for us, it's a relatively new space and a lot of either overlap or scope gaps in terms of who's doing what. So taking the time to get that protocol and where responsibilities stop and start is something I'd highly recommend taking some time to do. Seeing pictures of the tag panels, one little lesson learned was trying to get seismic into was a lot of fun. So we ended up having to leave some channels out, which then means it's site built, which then means it's not prefab. So again, most of which boils back to the common thread of early planning. Our original plan logistically was to have one crane right about there that could serve the whole project. Looking at our sequencing, virtually every piece of the structure you can see, the left shows it slightly better, is craned into place. Prefabrication becomes a battle for hook time. We're looking at projects at the moment with concrete cores. If there's a way to do like a self-climbing core, or in the case of this, get a second crane, like if you can either increase your hook capacity or somehow become more efficient, it is likely your hook time will become your restricting factor. So give that plenty of attention. We haven't run how long it would have taken with one hook, but it would have been significantly longer if we hadn't have stuck the second hook in there. Not as effective on the tag panels, but super relevant to the CLT. Moisture management. In planning this project, and we had a while to do it, if you asked 9 people, you'd get 10 opinions of how you moisture manage CLT. Some people are adamant you cover it up. Some people are adamant you don't. Some people have this theory, just build it in the summer and it'll be fine. And good luck with that. Truthfully, I don't have a lesson learned for you other than we will do probably 6 months from now. So because lots of people wanted to cover it, lots of people didn't, we've actually alternated the floors. So we've gone uncovered, covered, uncovered, covered, and we're going to see. We've brought in a moisture management company. We've got something like 130 sensors all drilled into the underside of the CLT panels across the project. And we're going to actually track what that does over time in terms of drying out. Logics being, just to really geek out on you, is that an uncovered panel might absorb more water, but it can dry out quicker because it's got nothing keeping the water in the top. It's got 2 sides to dry out. Other logic being you protect it and the moisture doesn't go in. So we'll see. Maybe the next talk we can feedback on how that shook out. But it's a huge, huge consideration, particularly when you're going with exposed undersides. The amount of rework to make those look respectable, even once you've dried it out, is a really significant factor, certainly on Vienna and anything else, particularly when you're doing flat CLT where it can sit and start to get into the product. Final kind of point, I sort of touched on it earlier on, but it requires bravery to do this. I can't imagine there's many people in this room, if I said, hey, you've got $50 million to spend on a project, would you like to do it the way that's been done 1,000 times before with like 100 years of doing this that has a lot of certainty? Or do you want to kind of bet it all on black and develop the industry, maybe lose your shirt, but it's okay because the next guy will have it better because we've learned something. There's not a lot of people taking that bet. We've taken a few projects through pre-construction in the kind of prefab model, only to fall at the final hurdle when they've seen the price and been like, no, we're not doing that. We'll do it the way we've always known. You are going to have to, as a group, as an industry, start to harbour and foster the idea of, we need to produce 1 million units a year, I think, and we're producing 200,000 currently. With systems like RC frame and stick built that are matured. They're not going to get any more efficient. Not to mention the fact we actually don't have the labor to build those things. We need to move the industry forward somehow. So you're going to have to ask your clients and your funders to be brave. Doesn't happen by accident. We're very fortunate that BC Housing and a lot of the people in this room were willing to be brave. But we are just like the tip of the sword. We need to do 10 of these, 50 of these, 100 of these, and then maybe figure out what we're doing. That's pretty much everything I had to say in terms of lessons learned. We're a little over halfway. We're due to finish in December, so we'll have a ton more by then, not least on the moisture management, and I'm sure we'll have some other hurdles along the way.